Okay, students, here's a overview conceptually of this lesson inverse functions 10.5. Well, let's see. Probably be a good idea if we would take a moment and review the idea of composites. So here I have F and here I have G. I want to know what fog of 2 is. Remember, fog is just F of G of 2. Take 2, put it in for G. When I do that, I get 8 out. Then take that value, put it in for F. 8. What is 8 plus 2 according to the directions? That's 10. So fog of 2, or F of G of 2, is 10. All right, now how would I do this problem? How would I do GOF, or G composite F of 3? Well, let's see. Let's erase the numbers so we don't get all confused here. So we're going to take 3, which of course this means G of F of 3. All right, so we're going to take 3 and put it in for the F function. 3 plus 2 is 5. I'm going to take 5 and put it in the G function. And I know everybody has their charts memorized. That's 125. So that is 125. All right, so keep that in mind. Now, here's a question. Matter of fact, I would say an excellent question. And how do I do fog of X? Okay, now I did it one way before. Let me show you another way to do this. Go to the F first. Isn't that just blah plus 2? And what would I put in for that blah? I would put G of X, which is X cubed. So fog of X is X cubed plus 2. All right, let's try that again. Could you give me GOF of X, or G composite F of X? No numbers, we need an expression. Well, let's see, how am I going to do that? Well, I'm going to go, like I'm reading from left to right, I'm going to go to the G. Isn't that blah cubed? Blah cubed? It is. And what am I going to put in for that? I'm going to put X plus 2 cubed, which means you'd have to multiply that out 3 times. I believe the first one would be X cubed. I believe the last one would be 8. And then I believe this would probably be, let's see, 3 times, well, we can multiply it out using box method. But I'm going to stop right there on that. Now, I want to be sure you're getting this. So can you tell me what F composite F of 3 is? Well, what does that mean? See, if you know what it means, then you don't have to memorize. So we're going to put 3 in for F. 3 in for F. And I'm going to get 6 plus 1 is 7. Uh-oh. It doesn't say anything about G. I'm not even going to use the G box. That was just trying to distract you. I'm going to put that 7 in again. So what's that going to be? I'm going to put the 7 into the value into the function again, and this time I'm going to put the 7 in. That's going to be 2 times 7, which is 14 plus 1 is 15. So F composite F of 3 is 15. All right, so does that make sense? I hope it does. All right, let's talk about inverses and numbers. Could you tell me what the inverse of A is? Well, the inverse is just switching the A and the switching the X and the Y. Here's an ordered pair. Instead of 1, 2, it's 2 comma 1. Okay, and instead of 4 comma 5, it's 5 comma 4. I guess if that mixes me up, I can understand why students get mixed up. Now, these A's are looking the same, so we're going to put a minus 1 here. That does not mean 1 over A. That is called inverse A. Inverse A. So keep that in mind. By the way, is this a function? Yes. And is this a function? Yes. So both the function and its inverse are functions. Keep that in mind. Okay, so in the last one, I gave you numbers and you were able to find the inverse. Now can you do it algebraically? Someone says, oh, piece of cake, Mr. Staples, because I'm taking something, I'm timesing it by 3, dividing it by 2, and then subtracting 5. So I'll take that something, I'll call it x, I'll add 5, and this time I'm going to take that and I'm going to times it by 2 and divide it by 3. And someone says, wow, how'd you know how to do that? I go, that is a very good question. If you saw how to do that, that is fine. But let me give you the 4-step procedure. Step number 1, change f of x to y. It's just the domain value, okay? No big mystery there. Okay, second step, switch the x and the y. Remember, that's what we're doing this entire time, was switching the x and the y. Now, I have an equation. You can call this a literal equation, okay, because it's letters. I just want you to solve this for y. And the way to do that would be to move the 5 first. So x plus 5 is equal to 3 over 2 times y. Now, what is the easiest way to do that? The easiest way to do that is to cause that coefficient to be 1 by multiplying both sides by 2 over 3. By multiplying both sides by 2 over 3. And notice when I do that, on the right side, these divide out and I have just y is equal to, then over here, I have 2/3 x plus 5. Or inverse f of x is, how about I write it this way? 2 times x plus 5 over 3. That's another way to write it. So that is a way how to find inverse functions algebraically. Step number 1, change the f of x to y. Step number 2, switch the x and the y. Step number 3, solve for y. Step number 4, write f of x or f inverse x for your y. Hope that helps. Okay, now we have a graph. We did it numerically. We did it algebraically. Now, not to nag you or anything, but we are going to do it graphically. So the question is, here the coordinate plane is black, and my graph or my function f is red. So here's f. Okay, it doesn't continue forever. The question is can I graph inverse f on the same coordinate plane? Well, we could do this a couple ways. We could do it algebraically by finding the algebraic function for this, or let's combine some of the things that we did. For example, how about we just do the numbers? All right. What is this ordered pair right here? It is 2, -1. We can call that point A. What's point B? Point B, it looks like 3, hopefully I'm doing that right, 3, 3. All right. Now let's just take the other color here. We'll take the blue and we'll switch it. So -1, 2. -1, 2. Instead of A, this is inverse A. And how about point B, 3, 3, switch them. Oh, what do I get? I get 3, 3. So its inverse is the same point right there. Now the question is could I graph the inverse function instead of the original function in red? Can I graph it in a different color, the blue? Why, yes. Okay. So the blue would not be f, the blue would be inverse f. That makes sense? Now someone says, oh, I'm beginning to see this because all you're doing is you're switching the x and the y. You're switching the x and the y. So, in other words, whatever the point is here, whatever, if it's x comma y, it's reflected across this line right here like it's a mirror, and that would be y comma x for its values. And that's true for every point up and down the original function. It's got a reflection over here. I hope that makes sense. Okay, we're going to call this bonus problem. Can you find the inverse of that function? That's a very good question. All right, remember the steps? Step number 1, y is equal to the cubed root of x plus 1 minus 3. Second step, switch the x and the y. I mean, isn't that what we did with the relation? Isn't that what we did with the graph? Now, you want to solve for y. So let's move the 3. Okay. Remember, we want to get the y out of there, but this argument or radicand has to be released, okay? And it's stuck because it's a cubed root. What is the opposite of a cubed root? The opposite of a cubed root is to cube. So now I have x plus 3 cubed, we'll just leave it like that, okay, is equal to y plus 1. Now what can I do? Remember, solve for y. Well, just subtract a 1. So y is going to be equal to x plus 3 cubed minus 1. And of course, the last step was, now that we solved it for y, rewrite it as inverse f. Inverse f is equal to x plus 3 cubed minus 1. And that's the inverse function. Okay, students, you could find this chart in the Lesson 10 discussion introduction called Parent Function Graphs. I suggest you download that and print that out and put it in your notebook. But anyway, these are all of the parent functions, okay? The parent functions. So keep that in mind. Make sure you know the name. We're going to play the game, Who's Your Parent? Okay, what's the parent function? So here, the parent function is the absolute value, the quadratic, the cube, the line, and the square root function. Those would be parent functions. Okay, we're going to play the game graph the function in its inverse. Notice over here, that is a cubic equation. So it's plus 1 inside and minus 3 outside. All right, this is y equals the cubed root of x, but it was plus inside, which is to the left 1, and it was down 3, 1, 2, 3. So that was the graph of the first function. The question is, can you tell me what the graph of its inverse is? Well, we could flip this across the line y equals x, or we could realize that the function is a cube minus 1. So it's plus 3 inside, minus 1 outside. Here's the cubic right here, y equals x cubed. Remember, it was plus 3 inside, so it's to the left 3, and then down 1. And sure enough, that would be the graph of its inverse. I hope that helps. If you go back through that, you'll notice that that does match. Okay, can I do this on my calculator? Well, I typed this into the equation editor and I hit graph, and there's the graph of that function. Now, if I looked at the table, I see the table of values, see? Okay, so what would the inverse be? Well, negative 3, negative 1 would have to be, the values would have to be switched. Now, the question is can I draw the inverse? Yes, you can. Here's how you do it. You go to your draw, second draw, and you're going to go down here to draw inverse, and you're going to tell it to draw the inverse of function y1. You get to there by hitting the vars key, y1, so inverse y1. And lo and behold, believe it or not, okay, it'll draw the inverse function. And that's exciting. I appreciate it. Hope that helps.